We had a beautiful morning for the 77th launch of the Space Shuttle program, the first shuttle launch with a full set of the new modified Block 1 engines. At T-minus 6.5 seconds, the main engine start sequence began, and shortly thereafter, with all three engines up to speed, we're on our way. With the SRB booster ignition, Endeavour was on its 11th mission into space. After clearing the tower, we rolled to the ascent attitude, heads down, which was going to place us in the 39-degree inclination orbit with an altitude of about 160 nautical miles. At this point, Endeavour and all its systems were consuming about 3,000 pounds of fuel and propellant per second, about the weight of your car.
For a first-time flyer such as myself, the ascent was really an amazing and wonderful experience. I was on the flight deck and I could look out the overhead windows with a wrist mirror, and I could see the flame in the flame trench prior to liftoff. I could see the flash of the SRB ignition and then feel the lurch as we were accelerated upwards. Into the flight, we saw a flash out the front windows as the SRB separation motors fired, as you can see here. Then we could feel the steady acceleration that carried us on up to orbital velocity and orbital altitude. It was a wonderful ride. As soon as we got on orbit, we had to start work. The first business of the day, as you know, is to open the payload bay doors and expose the radiators that line the doors in order to provide cooling for the spacecraft during its subsequent on-orbit operations. Here you see the starboard door being opened, and it'll be followed shortly by the port door. In the payload bay there, you can see the Spartan spacecraft and the gold-covered canister which contains the inflatable antenna, which we will be showing shortly and which we deployed on the second day of the flight.
When we first get up on orbit, it is a very busy time after the engine shut down to configure the rocket ship to be an orbital spacecraft. But the lure of the windows calls, and everybody tries to get to the window to sneak a first view. While the flight deck crew was configuring the ship for on-orbit operations, I was down on the mid-deck doing the same for the systems down there, as well as helping each crew member unsuit and get ready for on-orbit.
After the post-insertion phase, Andy Thomas and I were on our way to the Space Hab, and of course a very exciting moment for us here where we're opening the hatch to the Space Hab, because this is where we're going to spend the majority of the next 10 days, and obviously eager to see that everything looks fine, and certainly from our first look in there, it looked as if Space Hab had traveled very well. Meanwhile, pilot Kurt Brown is in the mid-deck, also doing some more configuration on orbit. Here you see the ergometer, which is sort of an exercise bicycle that Kurt is assembling down on the mid-deck. The ergometer is a very popular device used by all of the astronauts, usually on a daily basis, to get a little bit of exercise so that we can strain our muscles a little bit. Also on day one, we had to check out the arm because we were going to use it later on for Spartan deploy and retrieve, and Andy Thomas did all the checkout on day one with the arm and also a payload-based survey.
After Andy checked out the arm and assured me that it would work, I had the good fortune to be in charge of the deploy of the satellite. Here you see a view of the grapple of the satellite, the end effector of the arm coming over the grapple pin. This is a view from the camera A in the front looking toward the aft, and this is the same view I had because the Space Hab in the payload bay blocks your view, direct view of this task, so we had to use the camera. What we had to do is lift the spacecraft up to a certain level above the payload bay and then bring it forward. In this case, forward is toward the background of the picture where you see the two windows of the cockpit where the operations station is. In the course of that evolution, we wound up flying over Egypt. Here you see in the background the Nile River, the Aswan Dam, and Lake Nasser. That all took place in daylight. The deploy actually took place as we went around the dark side after sunset. Here you see the deploy. We'd have to ungrapple put the arm in the ungrappled position and then back it away from the spacecraft. And after backing the arm away, John and Kurt then took the orbiter and backed it away from the satellite.
The deploy itself was in the night phase, but in the next orbital sunrise, sun sensors, which were positioned on the Spartan spacecraft, initiated the deployment of the inflatable antenna and its subsequent inflation. As you can imagine, this was a particularly impressive sight. In fact, it was spectacular seeing this from the orbiter. We were just 400 feet away looking down upon the Spartan, and we saw this sequence that you can see here. Doors on the Spartan carrier opened, and the antenna mylar structure was pushed out into free space, as you can see here, and then inflation started by filling it with nitrogen gas, and in a moment you will see one of the legs of the antenna fill out with nitrogen gas, a bit like water in a fire hose. There you see it. Antenna structures like these have a lot of applications. They can be used for antennas for deep space probes. They could be used for radar mapping spacecraft of planets or Earth observations, or they could be used for sunshades for orbiting space stations. My crewmates tell me here that the legs look a bit like the number 77 when viewed from Earth. This deployment and inflation took place as we were crossing the west coast of the United States, and you can see that in the background as we're crossing over California. And in a moment you will see us crossing over the dry lakes of Edwards Air Force Base. You can see the inflation continuing, the last leg of the antenna being deployed. You can see the gyrations that the spacecraft is going through under that action. The antenna, when it was deployed, was nearly 100 feet long, bright silver, nearly 50 feet in diameter. And since we were only 400 feet away from it, you can imagine that it was a really grand sight to see from orbit. After a few moments, the instabilities created by the inflation settled down, transient settled out, and we got a stable antenna in orbit. This shows a view of the canopy itself after the inflation. You can see some ripples following the inflation process. We tracked it for one orbit while it did self-measurements of its shape, and then we jettisoned the Spartan spacecraft from the antenna. And the next frame will show you the jettison process, and I draw your attention to the canopy disk itself, where you'll see a shock wave that envelops the canopy as the pyros fire and dump the Spartan spacecraft. There, you see it. A bit like striking a 100-foot diameter drum. The jettison took place again as we were tracking over the United States. We didn't retrieve the antenna itself. It subsequently re-entered the atmosphere and burned up a couple of days later. The following day we went back to retrieve the Spartan itself, which you can see in the lower part of the screen there as a small black speck. And this is our farewell view of the antenna as we're crossing over the Midwest region of the United States.
As Andy said, the next day we went back to pick up Spartan. This is a view looking out the overhead window. You see the Spartan at a few hundred feet in the optical site. This is now a view looking out, a payload bay camera looking straight up. You see the RMS, the robotic arm on the right, and the Spartan on the left, about 100 feet. Mark Garneau very carefully getting ready to retrieve the Spartan and to grapple it. The grapple occurred at nighttime, so it was a bit of a challenge for us to adjust the cameras for him.
Fortunately, Dan did some adjusting on the camera parameters, and we got a good view of the end effector. And here's a view from an aft camera. You see the end effector of the arm moving over the grapple fixture. John did such a great job of bringing Spartan in. It was rock solid. It was a very easy job for me just to move the end effector in over it and to close the snares, and then to do the rigidization. You might observe when the rigidization takes place, you're pulling in the Spartan. And also the arm sort of goes limp, and it looks like everything's sort of shaking around a little bit. But after capturing it, the Spartan folks wanted to have a look at it, so Andy rotated it a little bit, and we pointed it at cameras, and then we had to put it away. Obviously, it had all the data that the Spartan folks wanted to retrieve to analyze after the flight. So there you see the Spartan being put away. It's a very busy time, retrieval. You can see a lot of people on the flight deck, everybody doing part of the job to make sure that we get Spartan back. And just in case you'd forgotten what mission number we were.
Very next day, we deployed our second satellite. It's part of an experiment called PAM-STU. This small satellite weighs about 115 pounds. It's aerodynamically stabilized and magnetically damped. The whole idea is to produce a satellite that perhaps doesn't need active stabilization. What you're looking at right now is the heavy end of the satellite, and we deployed it radially towards the Earth, and eventually that heavy end did orient itself into the velocity vector. Again, it's kind of tough to concentrate on the small satellite in the center when you're passing over sites such as this, North Africa, the coast of Portugal and Spain, and the Straits of Gibraltar that you see at the top of the picture, and coming into the Mediterranean Sea again at the top of the image. The STS satellite had a series of laser reflectors that were designed to be tracked by a laser in the payload bay. Additionally, many of us used a handheld laser in the window, and this was to give us range information into one of our relative plots that we had on board so we could maintain station keeping with the STS satellite. We station kept about 2,000 feet behind the satellite, which is something that had never been done before, and we did that 3 times. Kurt flew 2 of those rendezvous in front of the laptops you see right now. Kurt's looking at, to the right-hand side, you see he's looking at a station-keeping box that, and they both, John and Kurt, did a great job of keeping us in the station-keeping. You see the PAM-STU now is only about 20 degrees off. It did end up with about a 20-degree cone.
In addition to these rather spectacular satellite deploy and retrieve operations, we also were lucky enough to have a space hab module in the payload bay, which provided us a lot of room to conduct some scientific experiments. Here you see Mark working on one, a crystal growth furnace that ran very successfully throughout the flight, and Dan and I working on various experiments in the space hab. We had 12 experiments in all, looking at the effect of microgravity on physical processes, material science, and some biological or biotechnology samples. It's a very good working environment to have the Space Hab module, and we enjoyed working back there. Some of the experiments were mounted in the mid-deck, and here you see Mario activating one of the biotechnology experiments that we carried in the mid-deck for this flight.
And of course, we had our usual unofficial experiments. Here we have the ball of water with a ball of air that's been injected into it, and a good demonstration of physics. One image is inverted and the other is back upright. But this time Dan was getting thirsty and asked me to prepare a tropical punch ball, which he very adroitly took care of.
Well, as with most of our shuttle missions, our on-orbit timeline was very busy thanks to our flight activity officers. And however, we did find some time to have some meals together and share our experiences on orbit. The mid-deck's quite small, but on orbit with 6 people, you're able to take available all space. Also, other activities, taking care of the morning mail from Earth for upcoming rendezvous. Andy's busy typing some family mail to be sent back down to Earth at next available opportunity. And on the mid-deck, John is busy exercising. Again, we all try to stay in good shape for our inevitable return to Earth. And Mario is putting away the vacuum cleaner. He's been busy doing some scheduled maintenance that we do each day to keep the orbiter atmosphere in pristine shape. Andy wasn't quite that busy. He was catching some sleep. Back in the Space Hab, this is our sleeping configuration in a sleeping bag with a head restraint and a little eye patch, and relaxed with the bungees across to give you some pressure in the middle. Personal hygiene is always a challenge in space. Dan here is working with some contact lenses. We do use contacts in space, and they work quite well in the zero-G environment, and there you go.
I think Andy and the flight design team got together to plan STS-77 so it would pass very frequently over Australia, shown here. This is a view of the northwest coast, Sharks Bay specifically, rather spectacular. When you look at the Earth, the blues and greens are just spectacular. Here you see from our low light level camera looking down at the Earth over Florida specifically, the flashes you see are lightning flashes from a line of thunderstorms that were passing over the state at that time. And in the center on the left there, those lights are cities, and that one moving off the top of the screen now is Tallahassee. Here you see a view, a rather spectacular one, moving over Mexico. This is a view looking over the Rockies westward. Toward the Gulf of California, Baja California, and out in the distance, the deep blue of the Pacific Ocean.
Unfortunately, all great missions have to come to an end, and that's signaled rather dramatically by the closing of the payload bay doors, which you see here, the starboard door coming into close. And you can see Spartan not looking quite so big in the payload bay now that it's lost its inflatable antenna. But we proceeded through the deorbit prep phase, as it's known. This was choreographed by Mario rather well, and he's taking care of people putting on their suits. I won't describe the feeling of sticking your head through. You probably can imagine what it's like, but obviously we have to wear these suits. And here we have our pilot, Kurt Brown, and looking out the window to his right, you can see the orange glow that's beginning to increase. And this is an overhead view through an overhead window, and you can see the light show that's going on, sometimes rather spectacular as arcing takes place in the plasma above you. We're now getting back into gravity. As you can see, John is holding this cue card up, and it's about a half a G.
In this shot, we've slowed down from our orbital speed of 17,500 miles an hour to about 300 miles an hour, and I'm hand flying the orbiter around the heading alignment circle at about 4 to 5 miles above the shuttle landing facility. It's always amazing to me that this vehicle, which has been our on-orbit laboratory and spaceship, now is configured and comes down and lands like an airplane, with, of course, one big exception: there are no engines running. So we're a high-speed glider, but very, very versatile spacecraft, and of course the only one in the world that can come back and land on a prepared runway. Touching down here a little over 200 miles an hour, we'll deploy the drag chute to help us slow down. Our flight had covered about 4.1 million miles. We're trying to file for frequent flyer miles. And we'd been around the Earth 160 times. The total flight duration was a little over 10 days. And as you can see, it was beautiful weather at the Cape. On-time launch, on-time landing at first attempt. As we roll out to about 60 miles an hour, jettison the drag chute. And a very happy crew after the flight.
Flash of the SRB ignition, and then feel the lurch as we were accelerated upwards. Into the flight, we saw a flash out the front windows as the SRB separation motors fired, as you can see here. Then we could feel the steady acceleration that carried us on up to orbital velocity and orbital altitude. It was a wonderful ride. As soon as we got on orbit, we had to start work. The first business of the day, as you know, is to open the payload bay doors and expose the radiators that line the doors in order to provide cooling for the spacecraft during its subsequent on-orbit operations. Here you see the starboard door being opened, and will be followed shortly by the port door. In the payload bay there, you can see the Spartan spacecraft and the gold-covered canister which contains the inflatable antenna, which we will be showing shortly, and which we deployed on the second day of the flight.
When we first get up on orbit, it is a very...
We had a beautiful morning for the 77th launch of the Space Shuttle program, the first shuttle launch with a full set of the new modified Block 1 engines. At T-minus 6.5 seconds, the main engine start sequence began, and shortly thereafter, with all three engines up to speed, we're on our way. With the SRB booster ignition, Endeavour was on its 11th mission into space. After clearing the tower, we rolled to the ascent attitude, heads down, which was going to place us in the 39-degree inclination orbit.
Busy time after the engine shut down to configure the rocket ship to be an orbital spacecraft. But the lure of the windows calls, and everybody tries to get to the window to sneak a first view. While the flight deck crew was configuring the ship for on-orbit operations, I was down on the mid-deck doing the same for the systems down there, as well as helping each crew member unsuit and get ready for on-orbit.
After the post-insertion phase, Andy Thomas and I were on our way to the space
with an altitude of about 160 nautical miles. At this point, Endeavour and all its systems were consuming about 3,000 pounds of fuel and propellant per second, about the weight of your car.
For a first-time flyer such as myself, the ascent was really an amazing and wonderful experience. I was on the flight deck, and I could look out the overhead windows with a wrist mirror, and I could see the flame in the flame trench prior to liftoff. I could see the